All right, welcome back. Today we're talking about transforming functions. So in general terms, there's 4 different kinds of transformations that we're going to look at doing on a function. The first one is the easiest one, translating. Translating a function means to move it left, right, up, or down rigidly. The second one is rotations. We're not going to be covering rotating functions in this class. That's something that would be more of like a Calculus 2 topic. It's kind of outside of the scope of this year. Reflections, so we can reflect over the x or y axis rigidly, so by keeping the scale of the function the same, but flipping over x or flipping over y. Dilations is to change the width of the function by stretching it. I always call it a stretch, but some people see it as like a compression. It depends on if you're grabbing it from the y-axis and pulling, or grabbing from the x-axis and pushing in. I always think of it from the y-axis and stretching. So let's talk about how we can do these transformations. So an example of this can be seen with the quadratic function, and we went over this in class on Wednesday. But if y is equal to x squared is the parent function, then y is equal to a times x minus h quantity squared plus k is a transformed version. And in that transformation, hk represents a vector on which the function is moved. So think of this as h being the amount left or right, but you need to make sure that you reverse it because it's baked into the formula as a minus, and k being the amount up or down, just straight as it is. In this transformation, a represents both the dilation of the function and whether or not the function is reflected over the x-axis. So if a is positive, there's no reflection. If a is negative, then the function is reflected over the x-axis. It also represents the dilation of the function. So if a is greater than 1, if the absolute value of a is greater than 1, meaning if a is positive 2 or negative 5 or something that is greater than 1 either in the positive direction or the negative direction, the function becomes skinnier. If the absolute value of a is less than 1, meaning if it's a fraction of 1, either positive or negative, the function's made wider because it's being compressed on the y-axis. Let's take a look at an example of this. So let's take the function y is equal to negative 2 times the square root of x minus 3, and then all of that plus 4. How is it transformed? So first, it's reflected about the x-axis. That's the negative part. It's stretched by a factor of 2, meaning if you were to grab it at the y-axis and kind of pull, imagine it being like a sheet of rubber or something. It's moved 3 units to the right, and it's moved 4 units up. So here's the original function. If x is 0, y is 0, x is 1, y is 1, x is 2, y is radical 2, x is 3, y is radical 3, and x is 4, y is 2. The transformed version, so to do the moving to the right, you're going to change each of the x values by moving to the right 3, so adding 3. So instead of going from 0 to 4, this is going to go from 3 to 7, because we're adding 3 to each of those. And then on the y part, we're going to take whatever the value that we're substituting, or that it was going to be. So for example, for 3, it was going to be 0. We're going to add 4 to it, and then multiply by negative 2, because that's the dilation factor. So 0, 0, what would have been there, gets moved to 3, negative 8. 1, 1 gets moved to 4, negative 10. 2, radical 2 gets moved to 5, negative 2, radical 2 minus 8, and there's a decimal equivalent to that. I'm sure most of you would prefer. 3, radical 3 gets moved to 6, negative 2, radical 3 minus 8. And then 4, 2 gets moved to 7, negative 12. So if you have this parent function here, and we did a graphic organizer in class where you should have your functions kind of all lined out for you, then so long as you know where it needs to be transformed, I honestly think it's easier to use this transformed version. But again, if you want to just substitute values into this equation, knock yourself out. There's no reason not to. But I think it's important to know, first of all, how to describe the transformation by knowing that it's stretched, move 3 units right, 4 units up, and also how you could possibly come up with that table of values just by knowing what the transformation is and knowing what the parent function is. So there we go. The assignment for this is on Delta Math. I made it a little bit easier than it was. Make sure you get that in by Monday. And have yourself a great day.